For this class, we'll discuss power. So we have the topic for today is power. Let us take, for instance, two boys, A and B, having to take up a particular task. So they have to lift a load of 70 kg along a distance of 5 meters with the same speed. If the first boy, A, was able to complete the task within the time frame and the distance required, and boy B could not, or probably stopped halfway, we can deduce that boy A has more power than boy B. So, by definition, power is simply the rate at which work is done. So, in a simpler term, we can say power is equal to the energy expended or work done per unit time. Then mathematically, we can say power is equal to work done or energy expended all over the time taken. Now, having said that, we say power is a scalar quantity. And why do we call power a scalar quantity? It is because it is measured by magnitude alone, without putting into consideration the direction of the application of this force. Okay. Now, if we consider the unit for power, power is measured in watts. And what is watt? 1 watt is actually defined as the rate at which the transfer of 1 joule or energy per second is done. I'll rephrase it. We can say that 1 watt is defined as the rate of transfer of 1 joule of energy per second. So therefore, we can say that 1 watt, 1 kilowatt is equal to 1000 watts. That is 1 times 10 raised to the power minus 3 watts equal to 1000 watts. So having said that, we would also like to take note of this particular concept, which is the electrical energy. We say that the electrical energy is measured in joules and electrical power is measured in watts or kilowatts. Take note that electrical energy is measured in joule and electrical power is measured in watts or kilowatts. So for instance, if a lamp of, let's say a lamp of 150 watts uses an energy at a rate of 150 joules per second, we realize that this same lamp will produce a brighter light than, let's say, another bulb of 100 watts, because this bulb of 100 watts is going to produce an energy at the rate of 100 joule per second. So these will produce a brighter light. The light here will be brighter than this one, than a lamp that produces an energy at a rate of 100 joules per second. That is why you see some bulbs, the bulb rating in some cases could be 100 watts, some will be 200 watts, and so on and so forth. So you realize that the bulb of 200 watts will produce a brighter light than the bulb of 100 watts. So let's say a car travels with a uniform velocity of 72 kilometers per hour. Or if you convert 72 kilometers per hour to meters per second, we have 20 meters per second. Now this car travels along a horizontal road and overcomes a constant frictional force of 500 Newton of 500 Newton while moving. Now, we can deduce the power of the engine from these parameters. Now, we say that the engine power of the engine will be equal to the work done per second. So what is the work done per second, which is equal to the force times distance per second? That is the force multiplied by the distance covered by that particular car in 1 second. So if you do that, what is the force given? The force actually is 500 Newton, and the distance was given as 20 meters per second. So if you multiply this, you have that the power of the engine is definitely equal to 10,000 watts or 10 kilowatts. Now, since this has been said, I would like us to note that 1 horsepower, 1 HP is equivalent to 746 watts, which is also equivalent to 3/4 kilowatts. So if we want to convert 10,000 from the example we gave earlier, if we want to convert 10,000 watts or 10 kilowatts to the horsepower counterpart, we would say that it is definitely equal to 10 times 4/3, or let's say 10 all over 3/4. So if you do the inverse or the reciprocal of this, we have 10 times 4/3, and this gave us 13 whole number 1/3 horsepower. Therefore, we can say that 10 kilowatts is equivalent to 13 1/3 horsepower. Now, having said this, I would like to give us a brief history of horsepower. Now, the term horsepower was adopted in the late 18th century by a Scottish engineer called James Watt. Now, he used this to compare the output of the steam engine to that of the power of a draft horse. So when the steam engine began to do the work of the power of the horse, and that was in the early 18th century, the mine owners began to ask many questions. They asked, how many horses will be able to be replaced by one engine? Or if I say it the other way around, how many horses can an engine replace? Now, James Watt therefore figured a mathematical way of equating the horse's energy to the energy of an engine. Therefore, the horsepower was invented, and I gave the equivalence of horsepower. I said 1 horsepower is equal to or equivalent to 746 watts or 3/4 kilowatts. This is where we're going to stop for this class. While in the next class, we'll solve some practical examples on power. So see you there.